Hi everyone, in this video we will understand the real meaning of an oxidizing agent and how chromate reagent react with alcohol. This video mainly for IIT JEE preparing students who want clear concept and mechanism along with important key points for revision. So, most of the students think oxidation. What is oxidation? So, oxidation is just adding oxygen. So, as we know, most of the students think that oxidation, if we ask them to define what is oxidation, they will say simply adding oxygen to a substance is called as oxidation reaction. So, yeah, that is what. So, let me explain with the examples. Here we can clearly see here methane. So, after reaction, methane converted to methanol. When we look at into the chemical formula, number of atoms, so new oxygen atom is added. Yes. So what about ethene? Ethene also there is no oxygen atom before the reaction, but after the reaction, what happened here? Epoxide is formed, right? So new oxygen atom is called, okay, according to definition, what is oxidation? Adding oxygen is called as oxidation reaction. Yes, so in the both cases, methane to methanol, ethane to epoxide, new oxygen atom is added here and here. So yeah, we can say that, okay, both reactions are oxidation reaction. Okay, what about then methanol to, okay, or alcohols to aldehyde conversion? Okay, let's see that. So what about here? So methanol CH3CH2OH, okay, so after reaction is converted into aldehyde. So but let's count, let's see, is there any new oxygen atom is added in this reaction? So okay, so there is only one oxygen, number of oxygens equal 1. What about here after reaction? Number of oxygen also here 1. So but there is no new oxygen atom is added. So then we cannot call this reaction is a oxidation reaction, right? So that is the not actual case. So look at the oxidation alcohols once again. So what actual changes is there? Any new oxygen atom is added? No. Since there is no new oxygen atom is added to the molecule, this is cannot be considered as a oxidation reaction. What actual change we can observe? Number of CO bonds. So what changes we can observe? There is no change in the number of oxygen atoms, but we can see here, so number of CO bonds, number of C and O, carbon and oxygen bonds. So in the methanol we having only one carbon and oxygen bond, but after reaction, so CO converted to C double bond O. So number of CO bonds are 2. Isn't it? This is the change we are observing. So what changes we are observing? One of the change, number of CO bonds are increased, right? Then what about hydrogen? So here this is our reactive side. So here the changes we are observing over here. So this carbon before the reaction, so it has 2 hydrogens, but after reaction we having only how many hydrogens? 1. So not only number of CO bonds are increased, but also number of hydrogens decreased, right? So increasing CO bonds and decreasing H bonds. Why along with the CO bonds H bonds are decreasing? So now you are making a new bond with the CO, oxygen. Already oxygen is existed in the atom, we are not added any oxygen atom, but you are making one more bond with oxygen, one more. Let's consider simple analogy. Making bond is a marriage process, right? You are making one more marriage with oxygen, but there is a legally, carbon can have carbon valency 4, carbon supposed to have 4 bonds. Bond means marriages, is supposed to have 4 marriages, but you are making one more marriage. If you, without removing, if you are going to new marriage, the number of bonds going to be becoming a 5. That is illegal. That's why we learn in the basics school level. So there, in chemical reaction, before bond formation there will be a bond breaking, right? Why? Because we have to maintain their covalency, right? So that's why here new bond is formed and one bond is removed, that is the CH bond. So right, so it is clear. Now let's define the true definition of oxidation. Oxidation is the simultaneous increasing CO bonds and removal of H plus ions as well as removal of electrons. So when you remove electrons, oxidation state of the atoms increases, right? You are making new C bond. So before bond making, there will be a new bond breaking. That's why we are removing H. Removing of H plus ion, removing of electrons and making CO bonds. So whenever the changes is there, so we can say, so the reaction, the change is what? Chemical change, and the reaction is what? Oxidation reaction. Don't think that just adding oxygen is called as oxidation reaction. If that is the case, so we cannot call this reaction is an oxidation reaction. Alcohols to aldehyde, but this is the oxidation reaction. So now we finalize the true definition for the oxidation reaction. What is oxidation reaction? Oxidation is a simultaneous. These things are happen simultaneously. So increasing CO bonds, removing H plus ions, and removal of electron. This is very important thing to remember. Okay, total oxidation mechanisms of organic compounds depends on these simultaneous events. So most of the reaction, these events takes place simultaneously. Yeah. So let's continue our discussion. Now, fine, we know that, okay, alcohols to aldehyde conversion is an oxidation reaction. But now I have a alcohol, I want to do that reaction. I want to perform reaction. So to do that, the work I having oxidation, I have to do that. So to carry out that reaction, I need a fellow, a chemical, a substance to do that. We need a substance, okay, that is desperate for the electrons, okay, someone extremely electron deficient. Okay, what is the name of the substrate? What we'll call? Now we need a substance to do some work. What is that work? We want to oxidize. Okay, so we have to oxidize a substance. So now can we call them as a what? We can give a name to them, right? How? Let me explain simple analogy. Like if you having any electrical work at your home, okay, so we will call an electrician, isn't it? So similarly, like for plumbing work we will call plumber. Now similarly same now I having a other work to do. What is that? Oxidation. Now I am calling a fellow. That fellow comes and do which work, Nana? Oxidation. So now like simply like LAC agent. Why we'll call them a LAC agent? The agent, his role is to do policy, LAC policy. So the name of the agent is given by his work, what is doing. Now I need a substance to do which work? Oxidation. So can I call him as an oxidizing agent? Exactly. So now to convert, as we know now, alcohols to aldehyde conversion is a oxidation reaction. To do that work, I need a guy, okay, I need a substance. Okay, so what is going to do? Oxidation. So now the name of that fellow is what? Oxidizing agent, right? So now we need a oxidizing agent. Now who can do that our work very efficiently? So now oxidation means what, Nana? Removal of electron. Okay, so electron removing, accepting. Now can anyone guess in the periodic table which element can effectively can do oxidation reaction? Any guess? So in the periodic table we have the most starving elements, manganese and chromium. Manganese and chromium, because they are in their maximum valence state. So they can, so now we already studied, school level variable valences, right? So manganese and chromium can lose maximum how many electrons? Manganese, so 4s2 d5. How many electrons it has? 7. So it can ready to lose 7 electrons and is converts to what? Mn plus 7. And chromium 6 electrons, Cr plus 6. So because they are in their maximum valence state, they are, and if they forms oxides like here see potassium chromate KMnO4, it is in a plus 7 oxidation state and it is surrounded with a highly electronegative atom oxygen. This fellow highly electron deficient. Again, these fellows are pulling electrons toward themselves, making this manganese effective electron, okay, highly electron deficient species. Similarly, chromium 2 plus 6, right? So now that's why, so we have a massive hanger to pull electrons from our manganese and Cr, Mn and Cr. So we can call KMnO4 and Cr, they are the kings of the oxidation. They are more effective electron thieves in the chemistry because they are dying for the electrons. So now we learn now what is oxidation, what is oxidizing agent, and which substance can act as a effective oxidizing agent. Because now if you are having any work, electrical work, so we need professionals we will call, because they having more experience, they will come and do work within few hours or less time and very efficiently, right? So that's what we'll call masters in their work. Now also we know oxidation, oxidizing agent, masters, the king of the oxidizing agent. Who is our king of oxidizing agent? Manganese and chromium. Why? Because they having maximum oxidation state of plus 7 and plus 6. But in this video we are going to discuss only chromate based reagent. I don't think so we are going to cover all chromate, but we'll cover only chromic acid. Okay, so we are going to now discuss about chromic acid reagent, how it will work on the alcohols. So we are going to now discuss more details about oxidation of alcohols by using chromic acid, oxidizing agent, and their mechanism. Yeah, one more picture for your better understanding. These are the demons. So now oxidizing agent is like a demon. Okay, Telugu will call like dayam. Okay, rakta pisachi. Dayam barte like the person is becoming very strong or weak. Weak because dayam blood dagutadi, right? Rakta pisachi. Then blood is here electrons. Okay, so oxygen can drink 2 electrons, means 2 bottles of blood, right? So then the fellow will become weak. That is called metal oxidation. When metals are oxidized, right, it's becoming very strong or weak, it's weakened, corrode. This is called as corrosion. Why? It's losing its electron. Who is drinking? Oxygen. Oxygen is the oxidizing agent. That's why remember like this simple analogy. What is oxidizing agent? Is a demon. What he want? He want to drink electrons, right? Yeah. So now the demons, kings of the demons, chromium and manganese. Why they are king? Plus 6 plus 7. Yep. So let's continue our discussion. Yeah. So now our specialist chromium trioxide, okay, but chromium, okay, we know that their oxidation state is +6, maximum electron deficiency, okay, and yeah, because it lost all d electrons. Now it's a d10 configuration. Yep, surrounded by oxygens. Oxygen is electronegativity group, again is making more deficiency. Now the thing is here, so the CO, what is happening, chromium oxide bonds simultaneously remove, okay, this we will learn later, we'll come back this for the later. Now let's focus on chromium. Yeah, now so the source of the compound is chromium trioxide. So is it is actually it is available in the solid state, like physical state, room temperature, it is crystalline solid, but we cannot use solid as such, so we have to convert into aqueous solution. So that's why we'll dissolve it into water along with sulfuric acid. So when we dissolve chromium trioxide in aqueous with sulfuric acid and acetone, so then it will convert into what, chromic acid. So this combination, the mixture of CrO3, H2SO4, water plus acetone or chromic acid, okay, in H2SO4 combination, chromic acid plus H2SO4 is called as John's reagent. It is prepared by institute because it is very unstable, that's why we have to prepare whenever you want, you have to prepare, just take the solid. If your chromium trioxide is not available, is there any other way? Yeah, there is the alternate way. You can take potassium dichromate or sodium dichromate, dissolve it in the acidic medium, that's it. So our reagent is ready. So our reactive active one is what, chromic acid, okay. So we dissolved chromium trioxide in water along with sulfuric acid, so we having our chromic acid. This is our reactive real reagent, or we can say active state, okay. This is the active thing, it will participate in the chemical reaction, right. So now we started from the oxidizing agent, then effective oxidizing agent, that is our chrome Cr plus 6. So then how it is available, chromium trioxide, then active one is what, chromic acid. How we prepare, dissolving chromium trioxide in the water with H2SO4, and also will add some extent acetone to, acetone is a solvent, right. So finally we having chromic acid. Now the thing is how this demon attacks. So దయ్యం బట్ట అంటే ఏం చేయాలి, ఎప్పుడు పడుతుంది, అర్ధరాత్రి శ్మశానంలో నడిస్తే దయ్యం పడుతుంది, isn't it? Yeah. So now there is a interaction, ఓకే, లేకుంటే శ్మశానంలోకి వెళ్ళి there are so many movies, right, ఒక థింగ్ ఒక ఏదో ఒకటి దొరుకుతుంది అక్కడ పట్టుకొని వస్తే దయ్యం మనతోడు వస్తుంది, రైట్. సో నౌ హౌ దిస్ డీమాన్ ఈస్ గోయింగ్ టు బి అటాక్, హౌ దే ఆర్ ఇంటరాక్టింగ్ ఈచ్ అదర్, దట్ ఈస్ కాల్డ్ ఎస్ ఎ మెకానిజం. సో నౌ లెట్స్ లెర్న్ ద స్టెప్ బై స్టెప్ మెకానిజం, హౌ దీస్ టూ ఫెలోస్ ఆర్ ఇంటరాక్టింగ్ టుగెదర్, వాట్ ఎగ్జాక్ట్లీ ఈస్ హ్యాపెనింగ్. Yeah, how does it initiate the reaction? So how reaction will start, right? Now we know that Cr plus 2 center is massive electrophile, okay, it is starving for electrons. Now so the kind fellow, okay, our ethanol, our alcohol having what, OH group, OH oxygen having two lone pair of electrons. Lone pair of electrons not participate in the bonding, they are free. Now this kind-hearted oxygen, what is do is act as a nucleophile and donates its electron to the chromium. That is what happens. So Sita Ramulina ఏం చేస్తుంది, even though that fellow is demon, she don't know what she do. అమ్మ భవతి భిక్షాందేహి అంటాడు, ఈమె వెళ్ళి ఏం చేస్తుంది, పాపం ఆకలితో ఉండదనేసి ఏదో తన దగ్గర ఫ్రూట్స్ ఏదో తీసుకుని వెళ్తుంది. దట్స్ వాట్ ఈస్ హ్యాపెనింగ్ హియర్, ద డీమన్ ఫెలో ఈజ్ ఎంటర్డ్. పాపం అవర్ సీత, ఓకే, ఆక్సిజన్ డోంట్ నో దాట్. నౌ షీ ఈజ్ యాక్ట్ యాజ్ ఎ న్యూక్లియోఫైల్, షీ డొనేట్స్ హర్ లోన్ పేర్ ఆఫ్ electrons to the demon. Now see what happens next. So this interaction is just simple, like as esterification. So in organic chemistry, how organic esters are formed. Carboxylic acid is having OH, alkali is having OH, C double bond OH plus OH, loose of water molecule forms ester. This is also similarly same thing. Okay, alcohol OH plus, okay, so your chromate reacts and forms ester bond. This is similar to the, that is organic ester, this is inorganic ester. Yep. So now, yes, this is our demon, starving for the electrons. So our Sita donating electrons. Sorry, don't take Sita, just okay, oxygen. Okay, let's come back to original story. Scientifically we'll discuss. We don't go unnecessarily. Yep, I want which color? Black color. Okay. So now, so lone pair of electrons, yeah, donated here. So then there will be a bond between them, CH3, CH2, H, oxygen. Okay, yeah, black. Now cover this way. Now we having chromium, Cr. So when this new bond is forming, okay, loses OH, then chromium you having C double bond O, C double bond O, OH. Okay, bye. Now see, carbon can have maximum how many bonds? 2 bonds. Carbon valence, oxygen can have how many bonds? 2. Oxygen valency how much? 2. But oxygen is having how many? 3. This is legal, illegal. So then immediately you're going to have positive charge. Then yes, it sacrifices electrons, and already we removed OH from the, okay, chromic acid, and again now we having H plus. Totally we are removing water. So removal of water, same similar to esterification, and this is called as the inorganic ester. So what happens here? Alcohols reacts with the chromic acid and forms, okay, chromate ester. Alcohol plus chromic acid, then we having here chromate ester plus water, right? Okay, now okay, let me read final product. Yep. So now chromium already having, I electronegative atoms. So now these electronegative atoms, pulling electrons toward themselves, and chromium is having partially positive charge. Now it starts pulling electron density through the, oxygen. Now we having this bond, right? Now it is connected to the rich family. Now, okay, so he trapped one of the innocent girl from the family. Now through this girl, okay, now he is pulling all the electrons from their family. Then as result, what happens? What happens? So their family also, so now this creates massive inductive pulling, and the alpha hydrogen atom becomes acidic. So now here we having hydrogen atom. Let me write this is, For better understanding, I want to write like this complete structure over here, H and H. So this is our alpha carbon, and the hydrogen which is attached to the carbon is called as alpha hydrogen. Now these two fellows are becoming very acidic. They are ready to sacrifice their blood for their sister oxygen. Right? Now this fellow send, who is our demon king, okay, chromic acid, sends his assistant to remove hydrogen, kill that fellow. Okay, so now our water, so now this is aqueous media, so water will comes now. Water is act as a Bronsted Lowry base, now is having lone pair of electrons and attracts and removes hydrogen as a H plus. So now this fellow is going as a H plus. Is not taking anything. So the bonded electron is still inside the bond. So where it will go? Now these electrons will move to CO bond. Right? Now means carbon going to make a new bond, double bond with oxygen. We know already oxygen is already having two bonds. Now it's going to make a one more bond. So but it's not illegal. Oxygen can have maximum two bonds at a time. Now since a new bond going to be formed here, then there is a breakage of bond. Now finally this cunning fellow receiving. This fellow is waiting for this electron, right? Now finally is gaining, is accepting CO electron. See, this is very important thing here. Okay, so now the kind oxygen donating lone pair of electron to chromium, okay, then forming ester bond. Now ester Cr is highly electron deficient, so it's pulling all the electrons, because this pulling is called as what? Inductive pulling. So that creating, so more acidic alpha hydrogen. Then water is coming, so in acidic media it is acting as a H plus acceptor, so removing H plus ions. Then CH bond electron, CH bond electrons are here, see here, CH bond electrons are moving to CO bonds. And once this is going to make a new bond between C and O, so simultaneously oxygen want to break this, so it is donating 2 electrons to chromium. So actually here, who is the victim? Carbon is the victim. Carbon losing her electrons. Carbon oxidation number is increasing. Carbon is losing blood. Okay, who is drinking? Our demon king. Demon king drinking carbon electrons. Okay, you cannot directly do that. That's why you made a bond here. Inductive effect, weakening the carbon bonds. Then is a simultaneous reaction. Is it clear now? So finally, what we gonna have? Our final product. Let's write our final product. Now, so CH3, no change. This is our reactive site. Before it has one H, now it has only one. And before it is single OH, now it's becoming double. See now, number of here, see here, one bond, but now CO bonds are 2. Number of CO bonds are increased. When it is possible, someone has to carbon. Okay, now carbon is like, let me explain, hydrogen has a wife. Now carbon want to make a new bond with a new marriage with other, so it has to give divorce. Giving divorce to hydrogen is very easy. Carbon, not possible. Carbon bond is very strong. Carbon hydrogen bond with OH. Okay, is the bond bond dissociation energy with having OH group electronegative atom decreases. That's why CH is easy. So that's why number of hydrogen atoms are very important. If there is no alpha hydrogens, carbon cannot do anything. Carbon cannot go for the new marriages, because giving divorce with carbon bond breaking is very difficult. Yes, it is making this process, making a new bond with oxygen, that only possible when the carbon is having hydrogen atoms, because carbon has to satisfy their hydrogen atoms, then only it can make it can make a new bond. Before new marriage, it has to give divorce. If it's having an innocent wife, it is easy to give divorce and it can make a new marriage. That's why we cannot oxidize what tertiary alcohols. No reaction. Why? Tertiary, 3 sides, we having 3 carbon. Okay, let me write that. Then that is also a very important thing to explain. Now see here, this is your tertiary. Okay, this is your alcohol. Even though this is going to be make a bond like this ester, but okay, even though this is induces the electron thing that is happens, but carbon cannot dare to make a new bond with oxygen. Why? So to make a new bond, either it has to break this bond or this bond or this bond. But what about in the secondary, at least you having one H, you having one H here, okay, you having OH here. Okay, if you want to make a new bond, okay, carbon will give divorce here, okay, to marriage with oxygen. Is innocent wife, but carbons are equal rights, both are now modern humans, not innocent. I am working, you are working, okay, no cheating, not possible, right? So now number of alpha hydrogens are matter. For what? Increasing CO bonds. That's why aldehydes can go further oxidation for the carboxylic acid. When anyway we are going to discuss it now. These that's simultaneous events are very important. Why alpha hydrogens? Why only primary alcohols to aldehyde with strong oxidizing agent like KMnO4 John reagent, or K2CR like John strong oxidizing agent, aldehyde alcohols to aldehyde, aldehydes to carboxylic acid is possible for the primary. Secondary, whatever strong or weak, only ketone. Why? So in the secondary, you're going to have only one hydrogen. You can make only, yes, double bond. Right? Okay, we'll come back to this discussion later. Let's continue now. Okay, leave it. So now come back here. So where we started, oxidation, then oxidizing agent, then masters in the oxidizing agent, oxidation. Right? Very professionals in their field. Who is that? Professional strong oxidizing agent. Who can become a strong, more hunger for the electrons, more electron deficient fellow with high valency. What is that? Chromium and manganese. Okay, we are discussing about chromium. What chromium is doing? Making ester bonds through the OH groups, then inducing electron, making massive inductive effect, pulling electrons and weakening CH bonds and sending water. Then water is acting as a base, removing H. Then bond electrons move to the CO. CO double bond is formed. Now that ester bond, what is formed initially, is taking advantage, taking all the bonded electrons, and finally she got what she want. Then she converted into, now see the oxidation state of the chromium before and after reaction. Finally now alcohols are converted into, now finally what happens? Alcohols converted to aldehyde. Fine. Now what about chromium oxidation state? Before it is place 6, finally one bond equal 2 electrons. She gained 2 electrons. Sorry, this fellow demon. He gained 2 electrons. Now this fellow has become now plus 4. This is oxidation and this is reduction. Now that is what we learned in our school level, right? Oxidizing agent, okay, do others to oxidation, for itself reduction. Sorry, yes, reduction. Is it clear? Yeah. Yeah. So what happens to our D main oxidizing agent reduced from the plus 6 to plus 4. And what about our alcohol? Oxidized. How? What changes we are observing? CO bonds increased. Before one CO bond, now two CO bonds, and hydrogens before H2. Now we having only one H. What about oxidation state of our carbon? Okay, now who donated to electron actually here? Who is the victim? Carbon. Who is the victim? Carbon. Papam carbon. Carbon lost her 2 bottles of blood. Who? To whom? Demon chromium. Yep. Now, finally, alcohol converted to aldehyde. Now I have a question. Yes, so alcohol converted to aldehyde. Is the aldehyde safe? Is the aldehyde safe? No. It is still surrounded by the demon chromic acid. But remember one thing, very, very important note, right? Even though it is there in the environment of demon chromic acid, but remember one important point, chromic acid cannot directly attack the aldehyde, right? Cannot directly attack aldehyde. So the demon came like analogy, Ramayanam Sita, when Sita is alone, no one is there, right? So what this happens, so this is something really, is connecting our story. So first, what Ravana did, okay, something I don't know the story, like names, he will send one fellow in the form of golden, what is that, lady laga పంపిస్తాడు, then సీత చూసేసి రాముడి పంపిస్తుంది. సో డైరెక్ట్గా డీమన్ రాకుండా ఫస్ట్ తన ప్యాత్ ఎట సెట్ చేసుకున్నాడు, వాళ్ళ అసిస్టెంట్ని పంపించేసి ఎవరు ఇంటికాడ లేకుండా చేసి దెన్ ఏ అప్రోచ్, రైట్? సో he cannot approach directly. So first he will send his assistant to make his path clear, then only he will enter. So now what I want to say here, this is something very important thing here. So what is that? Yep, chromic acid cannot directly attack aldehyde. Now the oxygen is in the form of C double bond O, right? As I told you, how they are interacting, initiating the reaction, this kind-hearted oxygen donating lone pair of electron, there the story. Okay, అసలు యాక్చువల్గా ద ప్రాబ్లం ఎక్కడ స్టార్ట్ అయింది, అసలు ఆమె గీత దాటి రాకపోతే రామాయణమే లేదు. ఈ కైండ్ హార్టెడ్ లేడీ ఆక్సిజన్ అసలు లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ కనుక మన క్రోమియంకి ఇవ్వకపోతే దెర్ ఇస్ నో ప్రాబ్లమ్ ఎట్ ఆల్, ఇజంట్ ఇట్? సో నౌ C is, okay, let me write, this is something very important thing to understand here. Now what is the difference between OH and C double bond O? Okay, now we having chromium, okay, papam plus 2 desperate for the electrons, electron deficient fellow, and here you having lone pair of electrons, here you having lone pair of electrons, right? The initial step is happening when this oxygen is donating to this fellow electron, there is a bond formation. Now he will enter to the family, then he will start disturbing the family members. Okay, if there is no interaction between these two fellows, there is no coming into the family, he cannot make any disturbance in the family. The only thing is happening, this interaction, oxygen to chromium, here also oxygen, here also chromium, but this is sp3 oxygen, but this is sp2 hybridization of oxygen. Lone pair of electrons are present in the sp2 orbital, here lone pair of electrons the sp3 orbital. sp2 s character is increased, electron negativity is increased, so high electric atom cannot donate that easily, right? But sp3 s character is less, donating nature is good, right? That is the problem here. So C double bond O, no, chromate cannot approach. So esters only forms with OH groups, right? So here you having OH, yes, good. So then what chromate will do is a demon fellow, then okay, గోల్డ్ లేడీ రూపంలో వన్ ఫెలోని సెండ్ చేస్తాడు కదా, అప్పుడు రాముడు బయటికి వెళ్ళిపోతాడు. అప్పుడు సి డబుల్ బాండ్ కాస్త సీత అప్పుడు పేరు లెక్క ఉండే డబుల్ బాండ్. రాముడు ఉంటే ఏం చేయలేడు, రాముడు బయటికి పంపేసిండు. నా దట్ ఈస్ వాట్ హీ విల్ డూ. సో నా సి డబుల్ బాండ్ ఓ he cannot approach. So now he will send his assistants. So now the reaction media is what? Acidic environment, and also we having aqueous water. So what they do? So carbonyl oxygen protonated and making it is highly electrophilic, right? So how these electrons C and oxygen and carbon electrons, now it moves towards the oxygen and it develops partial positive charge, or we can write, polarize these fellows like this. Now this is opening door, this is the positive. Now another assistant of Demon King act as a base, and you gonna have CH3C, okay, that is already OH, and one carbon with 2H. So can we call this is a hydrate? Carbon with the 2 OH group is called as what? Hydrate, or we can call gem diol. Okay, so now we having aldehyde hydrate or gem diol. Now tell me, so what is what our Demon King want? He's waiting for what? Okay, so Ravanasud is waiting for what? Sita alone ga undali, రాముణ్ణి బయటికి పంపాలి. దట్ ఇస్ వాట్ హ్యాపెన్ నౌ. నౌ అవర్ సి డబుల్ బాండ్ is converted to COH. Is waiting for ester formation. He cannot make ester with C double bond O. That's why he sent his assistant. Now they made his path very clear. Now the situation changed. The hydrated as OH group now, right? Now chromic acid now can now form an ester bond with this OH. So now our Demon King will enters, because now path is clear. C double bond O, C double bond O, chromium, OH and OH. Okay, so remove water molecule, or if you want you can show with the same lone pair of electrons and removing OH, the same thing. Okay, I'm writing directly. So now write CH3. Okay, so O, chromium, OH, double bond O, double bond O. Okay, so what left here? Yeah, here. Okay, I write alpha hydrogen over here and OH over here. Same thing. Then what you do again? Okay, massive inductive effect, pulling all the electrons through the C with the chromium and O bond, pulling all the electrons towards himself. Now that will make here this fellow more acidic. Same thing now again. Okay, water will come, Bronsted Lowry acid, abstract removes the H plus ions, water roll H2O, lone pair of electrons taking H. Now same migration of CH bond electrons towards the CH bond, right? Now yes, this fellow finally got what he want. Okay, again what happens now? What is our final product? CH3. This is becoming C double bond O and OH. Now where we started actually aldehyde CH3. Sorry, we started with alcohol, ethanol. 1 C bond to how many C bonds? 1, 2, 3. CO bonds how many? 3. Okay, so yeah, same. Now is it clear? So after the esterification, alpha hydrogen removed, electron shifted to CO to form C double bond O, and chromium finally accepted its electrons, not its electron, from oxygen chromium bond electrons. This leads further oxidation aldehydes to carboxylic acid. Now tell me, so who played major role in the second step oxidation reaction? Second step oxidation reaction. The Traitor water. What is the title? Over oxidation trap. The Traitor water. Understood now why we are calling it a traitor? If there is no water, if there is no golden, that Bangaru lady in the Ramayanam, there is no Ramayanam. Rama will be there with Sita. Okay, Rama, Ravanasudu raledu, Sita తీసుకెళ్ళలేదు. Okay, there is no war at all, right? So now these fellows, water, if it's not making carbonyl to hydrated thing, there is no interaction. Now it may be no formation of carboxylic acid, right? So the over oxidation is only due to presence of water, wet. That's why this is very, very, very important that we learn, special cases. Okay, let's conclude today's video. So now John's reagent is a powerhouse. Its over oxidation is a major, we can say this is a limitation, because if you want to do selectively, you want to start with alcohol, just you want to end up with aldehyde, you cannot stop there, right? This is the limitation we can say. So the limitations for what we cannot do for the selective synthesis. To solve this, our great chemist scientists developed the advanced reagent like PCC, PDC, that which we will discuss in the next video. Yep. So stay tuned. Bye bye.